Good day, everyone. It's Tutor Ginux here again. Welcome to another class. If you are new to this channel, do well to subscribe, do well to like, comment, and share this video. So in today's class, we're going to talk about radioactivity in physics. Radioactivity in physics. So, and this class is majorly focusing on the calculation aspect of radioactivity. So how are you going to tackle calculation questions on radioactivity? So that is what this class is all about. Don't forget that radioactivity is the spontaneous decay or disintegration of the nucleus of the atom of an element, during which it emits alpha, beta, and gamma rays, or a combination of any of all the three, and energy. So that is the definition of radioactivity. And another thing you need to know the definition before we get started with the calculation part is half-life. Half-life. So what is half-life? Half-life of a radioactive element is the time taken for half of the atoms initially present in the element to decay. So half-life of a radioactive element is the time taken for half of the atoms present in the element to decay. So because you are going to be using the concept of half-life in the calculation aspect, so that's the reason why you must understand the definition. So for the summary of radioactivity calculation, I'm only going to give one formula, and with that formula you'll be able to solve any calculation question on radioactivity. So this is the formula we are going to be using to solve questions under radioactivity, and the formula is as simple as this: nt over n naught is equal to 1 over 2 raised to power t over t half. And this is the definition of the parameters. N0 is the initial number of atoms at the beginning of the radioactive process. So the initial number of atoms at the beginning. Nt, that's the number of atoms remaining. Note this word, number of atoms remaining. It is not the number of atoms that decay. It is the number of atoms that remain after the radioactive process. Then t is the time taken for the decay. Then T half stands for the half-life. So with this formula, I'm going to show 3 or more examples on how to use this formula to solve radioactive questions. So this is a JAMB question on radioactivity. Let's solve this question using this formula. A substance with a half-life, that is the T half. Half-life is 5 minutes. Has a count rate of 500 after 15 minutes. So this 500 is a count rate remaining after 15 minutes. That means that's the NT, because NT is number of atoms remaining after a particular time. So 500 remains after 15 minutes. NT will be 500. T will be 15 minutes. That's the time taken to have a remainder of 500. What is the count rate at time 0? That is the N0. That's the initial number of atoms. Initial number of atoms, that's N0. That's the question. So with this now, you can make use of the formula. And some people might be wondering why we are not converting these minutes to seconds. Under radioactivity, you don't necessarily need conversion if the units of both time are the same. So you don't need to convert. If they are in hours and hours, you use it like that. Sometimes it can even be in years. We are still going to do another example that the unit of the time will be years. So you don't need to do conversion to seconds or anything. Just make sure they are the same. And with that, you can substitute directly to the formula and solve the question. So let's make use of the formula now. Nt over n naught is equal to 1 over 2 t over t half. Nt is 500. N naught is unknown. 1 over 2. T is 15. T half is 5. So let's just solve the question. 500 over n naught is equal to 1 over 2. 15 divided by 5 is 3. 500 over n naught. 1 raised to power 3, that is 1. 2 raised to power 3, that is 8. So to get n naught, we cross multiply. This will multiply this will multiply this. That is, n naught is equal to 500 times 8. And n naught is equal to 4,000. So that is the correct answer to this question. So this is another question. A radioactive substance of initial mass. So initial mass, that's the initial number of the atom, that is 8 grams. Has a half-life. The T half is 10 days. That's the half-life. How many days would it take 7 grams of the substance to have disintegrated? Please note this part. This kind of question can confuse you. How many days would it take 7 grams to have disintegrated? So what they are trying to say is that NT is not 7. NT will be the amount of gram that will remain after 7 gram has disintegrated. Please don't mix this thing, don't mix it up. NT stands for the number of atoms remaining. But in this case, we are told that 7 gram disintegrated. Disintegrated means it's decayed. Decay. So if 7 gram has disintegrated, it will definitely remain 8 minus 7. Don't forget that 8 gram is the initial mass. So if 7 gram disintegrated, that means the number of gram remaining will be 1 gram. You get this part? So NT is 1 gram. It is not 7 gram. So it's a tricky question. It is 1 gram. How many days? That means we have to find the time. The time taken for this 1 gram to remain. T is unknown. Then we are going to apply the formula. So NT over N naught is equal to 1 over 2 T over T half. And let's put in the values one after the other. 1 over 8 is equal to 1 over 2 T is unknown, then T half is 10. So from here, we are going to apply the knowledge of indices. 1 over 8 is the same thing as saying 1 over 2 all raised to the power of 3. Do you get that? That is 1 raised to the power 3 we give 1, 2 raised to the power 3 we give you 8. 1 over 2 raised to the power T over 10. So from here, you can equate the powers. Equate the powers. That is, the base number are the same. You can equate T over 10 to be equals to 3. Or 3 equals to T over 10. It is still the same thing. Cross multiply. T is 3 times 10. So T is 30 days. So 30 days is the correct answer. Now, this is another JAMB question on radioactivity. But before I proceed, do well to like this video, drop a comment, and share this video so the video can reach more people out there. And if you are new to this channel, do well to subscribe to this channel so as to get updated when a new tutorial video drop. Thank you. A count rate of radioactive material is 800 count per minute. That is the initial. So N naught is 800 counts per minute. If the half-life of the material, T half, if that is 4 days, what would the count rate be in 16 days? That is, after 16 days, the time is 16 days, what will NT, what will it be? So NT is unknown in this question. Let's apply this same formula. NT over N naught is equal to 1 over 2 T over T half. So what is NT? Unknown. N naught, that is 800. N naught is 800, is equal to 1 over 2 T, that is 16, over T half, 4. NT over 800 is equal to 1 over 2. 16 divided by 4, it is 4. Raised to the power of 4. 1 raised to the power 4, that is 1. 2 raised to the power 4, that is 16. NT over 800 is 1 over 16. So NT will be 800 divided by 16. And that's going to give 50 count per minute. Option C is correct. If you have any question on radioactivity, drop it in the comment section below. I'll make sure I attend to the question. Thank you very much. See you in the next video.